Hey everyone, I am Aaron Bewley and I'm a hyperconverged specialist as part of our Converged Platforms and Solutions division within Dell EMC. And tonight we'll be talking about VxRail. So first of all, thank you Pilium for putting this on for us, and thanks Mark for helping me get this set up. If you would like to reach me, if you have any questions, you can see up there on the screen my phone number is there as well. You can reach me on Twitter too. I have a lot of conversations there out in the open, out in the public, because often if you guys have a question, many other people do as well. So it's a great public forum to discuss this type of technology. So feel free. You can send me some messages live while you guys are watching this video, and hopefully I can respond. Let's move forward on this. So this is kind of a funny quote. It's funny to me because I'm an HCI specialist, and maybe it'll be funny to you after I explain what hyperconvergence is. But it's a famous quote from Henry Ford where he said, if I had asked people what they wanted, they would have said faster storage arrays, right? And so it's funny to me, he didn't actually say storage arrays, right? He said faster horses, and then came Ford Motor Company, right? So we're kind of part of this, this dynamic industry shift right now where historically what everyone has is external storage arrays. But what is climbing the charts and taking off really is the concept of hyperconvergence, of software-defined storage. All right, and so a lot of people don't know what they don't know, right? They don't know that that the advantages of what hyperconvergence brings them. In the same way that you had a horse, I want a faster horse for my horse-drawn carriage. Well, what if I could give you 300 horses in an engine and allow you to drive 200 miles an hour, or probably couldn't go 200 miles an hour with only 300 horsepower engine, but you get my point, right? So this is kind of the design shift that we're in right now. So if you look over here on the left, what you see on the left is basically what everyone has, unless they've already adopted hyper-converged infrastructure. You have servers with external storage systems. And so what happened back in about the mid-2000s, more and more people started stacking apps on top of these servers. The problem was these servers are only 2 nines of resilience, right? So that means 99% uptime, which if you extrapolate that, there's 365 days a year. That's multiple days of downtime per year. So it doesn't make sense to have silos of storage in each of our servers and then just collapse all our applications to a single server. And EMC realized this back in the day and said, hey, VMware is killing it, right? They're doing the right things. Let's buy VMware. And realizing that buying VMware is going to grow the external storage market, okay? So when I start stacking applications on top of servers, I need a better resiliency plan. I need hardware-based resiliency, and I need a shared resource pool of storage. So in those external storage systems that EMC had at that point, we could get 5 nines and 6 nines of uptime, right? Which you couldn't get within a server. Okay, so then the idea is if I've got applications that are running on servers, my server dies, I don't care because that VMDK is sitting in that external storage system. And now if a server dies, it can just reboot elsewhere and the storage system provides the resiliency. So there's a lot of trends that are changing that and changing how we're doing storage, right? And how we're delivering resiliency and delivering performance, etc. And you can see them listed over there on the right, but the two main things that I feel carry the most weight here is the concept of software-defined storage for one, and then flash media and where it's come to at this point. So, but software-defined storage really allows us to provide that resiliency and that shared storage across server nodes. So rather than have an external storage system and deal with Fibre Channel or iSCSI or whatever and have that conversation, we can just take those VMs that are running on top of those servers, those VMDKs, and we can replicate it from host to host, policy-based, right? So I get the 5 nines or 6 nines uptime I want. I get the performance. I get the shared storage without having to mess with an external storage system, an external interface, another management tool, all that, right? SAN connectivity, multipathing, all that stuff, okay? So software-defined storage is now just a part of hypervisors, okay? Specifically what we're talking about here is vSphere, and the fact that vSAN is now part of the vSphere hypervisor. And we'll talk a little bit more about that in a little bit. The second thing on here is the idea of flash media. And I can tell you back when I started selling Clarion arrays, I started my career at Dell. And back in about 2006, I want to say, we were selling 36 and 73 gig drives. And if I recall correctly, they were around $10,000 and $13,000 a piece for a flash drive, which is, I mean, insane if you think about it today. But back then it was like, hey, I got to have the performance. And so we had these beautiful things, this concept called storage tiering. So we would take the hottest blocks and put it on the flash media, so that way we could be economical about when we buy that $10,000 drive, we're smart, right? However, the consumerization effect of what we've done with flash media, as well as just general technology trends and moving forward in time and things getting exponentially faster and cheaper, we're now looking at almost 4 terabyte SSDs. These 3.84 terabyte SSDs are 2.5-inch drives, right? They're not making drives that big from a 10K SAS or 7200 RPM nearline SAS drive. So we can load up a server with 3.84 terabyte SSDs and get 100 terabytes worth of storage capacity in a 2U chassis. And the economics of it, now that we've got deduplication, compression, and erasure coding on flash media, we're now at this inflection point where the price of flash is now lower per gig than the price of a hybrid system. So really what that means for us is we've got the capability to create a vSphere cluster, which really all you need within a vSphere cluster is compute. So I need CPU cores, I need RAM, and I need storage. So now the question is, can I get all of that out of an x86 system? And absolutely you can. You've got CPU sockets, you've got DIMM slots, and you've got drives up there in the front. So then the idea becomes, okay, how do we scale this system? If we want to stand up a vSphere cluster with software-defined storage, it just means let's stack together x86 servers, connect it with fast network in the back, so 10 gig Ethernet, and then we have the idea of a virtual storage area network, a virtual SAN, that creates one data store by pooling all those disks together that you see there across the nodes. And one of the really neat things about it is the fact that it gives us a lower starting point from a CapEx perspective, and then it gives us smaller steps incrementally as we scale those systems out. So in a traditional external storage system, where I have to get a storage system that can scale out to 1,000 drives as an example, but I only need to start with maybe 200. I'm arguably buying more CPU and RAM capacity than I need right out of the gate, so that way I've got the ability to scale down the road. Additionally, I may be buying a blade chassis that can hold X amount of blades when I only need this amount for right now, right? And there's some storage systems where you have to grow in large chunks, right? So if I need an extra terabyte, I may have to buy another 40 terabytes worth of storage just to get that extra terabyte that I need. So you can see from a traditional storage perspective, you're often going to the well once a year and you're writing a $500,000 or $1 million check. And so what that'll cause you to do is to overbuy, really, is to buy 2 or 3 years worth of capacity right at the gate, rather than buy what you need now instead of buying, next year's storage at today's prices. And so what hyperconvergence allows you to do is to get in at the level that you need, because all you have to do is put together, you've got pools of CPU, RAM, and storage, and we can do that within an x86 system, right? So we just determine, okay, this is how much you need, this is some slack space for availability and a little bit of growth, etc. And then as you scale out, you just add an extra node or add some drives to the nodes, okay? And then arguably that's a couple $100 or a couple $1,000 rather than $500,000 or $1 million to scale out that storage system. So completely different economics that are driving this. All right, so a lot of what we're going to be talking about revolves really around what we're delivering here with VxRail, and that concept is delivering vSphere in a box, okay? An appliance where you turn it on and I've got a vSphere cluster. But the true engine of what delivers that is vSAN, okay? Now you could go out and you can buy vSAN, you can buy an engine for your car, and then you can go buy a frame for the car, right? A chassis, same thing, right? You can go and buy vSAN, you can license vSAN, and you can go in and purchase a vSAN ready node, okay? There's a bunch of manufacturers of vSAN ready nodes. Dell is arguably #1 at that, right? Not to mention Dell owns VMware, so the integration of PowerEdge and VMware, vSphere, vSAN, etc., is going to be closer than anything else, right? But there's another option, right? So you can imagine piecing that car together for yourself, or you can go and buy a car, okay? So instead of building that out in your garage and making sure that the engine sits on the engine mount right, and you've got enough blinker fluid, etc., you can just go to the Mercedes dealership or whatever this car is here, and drive it off the lot, right? And this makes a whole lot of sense when the idea of having standing up infrastructure is no longer a differentiator for companies. Especially if you have multiple deployments, you have a lot of different locations, and you don't want to end up with disparate systems. You don't want to end up with a snowflake here and another snowflake there, and then try to remember, okay, how did I manage this one? How did I create that one? How did I build this car? It's, okay, there's a car. I mean, this is a Model S, this is a Model S, this is a Model S, whatever it is, right? And it's fully supported within what it is, right? And it's not like, oh, well, we were only able to buy these tires for that car and this windshield for that car, etc. So you get the idea. All right, so let's take a look at what VxRail is. First, we're going to talk about the hardware and some of the different platforms that you can use to consume it. And then we'll talk through some of the software, being that it's an all-inclusive appliance. So it's delivering hardware with software. The idea is, again, I mentioned this earlier, but it's vSphere in a box. So you've got compute in the back, you've got hard drives in the front, and it's designed, you power it on, and I'm delivering vSphere, okay? And I'll walk you through a demo of what this looks like. All right, let me just take a second and walk you through what the actual setup process is gonna look like whenever you receive a VxRail system. So after you pull it out of the box and put it into the rack, power it on, connect to networking, you're gonna hit the first node. There's an IP address, 192.168.10.200. That'll tie you into the first node within the cluster, and you'll get this splash screen and you'll walk through it. Let's go ahead and get started. So you've got this EULA that you'll obviously read every single word, you'll print off, you'll sign, you'll fax it back to your Dell EMC rep, and no, I'm just kidding. Just hit accept and keep moving. The system will automatically find the nodes that are on that network there. Once you see them show up, you can just hit next. And then there's two specific ways that you can configure VxRail. You can go through a step-by-step process, or you can upload a JSON formatted config file that basically just inputs all the information that the step-by-step process would ask for. So what I'm going to do is show you what it looks like to go through the config file, and then basically it'll just fill everything out for us, so I make sure that it's done right. So you just click on your VxRail configuration file, hit open. All right, so after we uploaded the JSON formatted config file, all that did was fill out all the stuff in the step-by-step. So now we'll click through it. But the idea here is that you can connect it to your time zone server or whatever. But you'll tell it how many NIC ports that you have within the nodes. If it's 2 or 4, you just click that there and hit next. Remember how I said you set up IP addresses, host names, and passwords? This is where you do all that. Okay, so you're going to tell it how you want to name the hosts there. So for instance, my hosts are going to be called ESXi01, and they'll just be iterated 01, 02, 03, 04, etc. Okay. I'll also give it an ESXi IP pool. So right there you can see that I've set aside 4 IP addresses. Now the neat thing here is if you set aside a large enough IP pool and you add nodes in the future, it can just intelligently take the next available IP address. So expansion of a cluster is phenomenally easy. It just says, okay, I see the next IP address that I'm going to assign here. Are you good with that? Type in your password, hit accept, and then the cluster will grow, okay? You can also see too that I've got the ability to join an existing vCenter server or create my own, okay? Also, you'll set up your IP address for your platform services controller, which is a new thing within vSphere 6 that helps you managing some licensing, stuff like that. VxRail manager, so you're naming the host, giving it an IP address, and then we give it ESXi passwords, vCenter server passwords, etc. That's it. And then there's 3 basic networks that you have to set up: the vMotion network, the virtual SAN network, and the VM network, VLANs. Okay, so we're going to separate the traffic on the back of those nodes. We're going to have one port that's dedicated to vSAN, and everything else is going to be on the other port. And so we're going to separate that traffic with separate VLANs. Now, if you had 4 10 gig ports on the back, you're going to have 2 dedicated to vSAN and 2 dedicated to everything else. Now, if one of those ports fails, we can fail the traffic over, so that way, you're not down just because you lost access to one port. So, additionally, this is where you would add and enable vRealize Log Insight if you wanted to do that. And then the last step really is to validate the system design, and then make sure that you're not set up to fail with the top of rack switch configuration. So it says the configuration is passed. Basic validation and network validation. Let's continue on to actually build the VxRail system. So the next button is to just build the VxRail system, start the configuration. So we sped this process up a lot. We sped it up to only take about 7 seconds. But the overall process is probably going to take around 15 to 20 minutes to do all this. But as you can see, it is very, very easy, and it's automating almost 300 different tasks. And all you did was put in some basic information, and then it's going out there and it's setting up your vSAN data stores. It's setting up your VM kernel NIC ports, and you just put in a little bit of information and you went and you got a latte. So maybe you watched an episode of whatever. You just went and got a latte, right? And so at this point, now you got your hooray screen, and the next step here would be for you to log into vCenter and just start provisioning VMs. That's it. Now the engine of this system is vSAN. Okay, so how does vSAN work? vSAN takes the direct attached storage disks assigned to each node and then pools them all together in one data store. So as an example, this specific node, I'm just kind of showing you the front end of this system I was just showing you. That node 1 has 6 drives. The first drive here is a cache drive. The rest of them are data disks. Same here, I've got a cache drive and data disks, etc., etc. vSAN will take all of those disk groups, create one data store, present that as part of, that's your vSphere cluster. When you provision VMs, you assign a storage policy, and then that storage just gets distributed across those disk groups intelligently. All right, so here's just a quick example of what it will look like whenever we build a cluster. Okay, so just an example of the resource pools. A lot of times when we're deploying this system that I'm showing you here, this is 3 of the 2 U4 node models, which equal 384 cores of compute, 228 terabytes of flash, and 6 terabytes of RAM, all in 6U. Now that's phenomenal. Okay, the types of environments that we're often collapsing to fit onto something like this are usually 1.5 racks to 2 racks worth of hardware, now going down to 6U. It's mind-blowing, right? And that's with our 3.84 terabyte SSDs. And at some point next year, we'll see 7, 15 terabyte SSDs. It's just getting off the charts. But the idea that we can get that type of density there is a huge benefit, a huge byproduct of, it's not so much the driver of what people are doing here, but it's a fantastic advantage of going with hyperconvergence. All right, so the big idea is to start small and scale out as needed, right? So start with the cluster size that you need, whether that's 3 nodes or 6 nodes or 7 nodes or whatever it is, and then scale out from there. So vSAN will go out to 64 nodes. That's because that's a vSphere limitation. Okay, remember vSAN is part of vSphere. It's part of the code. So whatever I can do with vSphere, I can do with vSAN. Whatever my limitations are with vSphere are what my limitations are with vSAN. So I can create a cluster, a VxRail cluster that goes out to 64 nodes. I would argue that nobody in the audience here has a 64 node cluster because I have yet to ever meet one. The vast majority of people are in that 8 to 16 node cluster range, and then they've got multiple clusters that they're managing. Okay, so it's the same exact thing that you would do with VxRail. If I've got this cluster for this business unit and this cluster for that business unit, and I'm going to go deploy VDI, etc., I would just have multiple clusters of 6 node, 8 node, 16 node, whatever it is. So, all right. And then one of the really neat things too of hyperconvergence is you start with that cluster size that you require, and then in 5 years, whenever the PowerEdge R9 Million comes out with 40 terabytes of RAM and whatever, you just add that to the cluster, and then vMotion over and drop off your old PowerEdge node. So what's beautiful about this is the concept of upgrading and moving into the future. I no longer have this idea of I've got a 300 terabyte external storage system and I'm moving to a 350 terabyte system. We've got to call a timeout, pause everything, pick up all the data here and move it all over there, which always equals downtime. I don't have that anymore. Okay, I've got a cluster with X amount of nodes. I'm going to add one node and I'm going to take one node out, right? So it's this idea, in my mind, I imagine this catapult going to battle, right? It's carrying your applications. And as it rolls forward, you're just taking one log off the back and you're putting another log in front, right? And so you just move in small iterations into the future. You're not picking up that catapult and moving it from one platform to another platform. So non-disruptive, very effective. Okay, so a lot of that is around what the hardware is. Let's talk about what's inside, the software that comes with it, and what makes it an appliance feel, okay? So remember, it's vSphere in a box. So what all does that include? It includes vSAN, it includes vCenter server, vRealize Log Insight, and it's vSphere ready, okay? So vSAN is that software-defined storage engine that allows you to make this a hyper-converged system. vCenter server, if you want to deploy a vCenter server internally, you can. If you want to connect it to an external vCenter system, you can. Pretty much anything you want to do with vCenter server, you can absolutely do. You also have the option to use vRealize Log Insight for analytics. We call it vSphere ready. Typically, customers already have socket licensing with an existing cluster that we're just replacing. So VxRail comes in, systems migrate over. When you shut these off, you take the vSphere socket licensing and you just apply it to VxRail. So it's ready for that, whatever additions it is that you have, standard, enterprise, robo, VDI, whatever. But we can bundle it in. If you want, we can just click a box and add the vSphere socket licensing too. So VxRail also comes with some deployment and support tools because it is hardware, right? And vCenter is not managing hardware yet. So what we have is VxRail Manager, okay? And that is really going to help you with your initialization, growing out the clusters, doing any sort of hardware maintenance that you need to do, firmware upgrades, software upgrades, phone home with support, engaging, if you have a trouble ticket or anything like that, searching knowledge bases, etc. Also, we've added in recover point for VMs, which is the gold standard in CDP and CRR, right? So if I want to have TiVo-like functionality for my VMs, recover point for VMs gives me that. It's taking a snapshot between every single write, and now I can roll back to any point in time with my local continuous data protection. Additionally, so vSphere comes with vSphere replication, but it doesn't get as granular as some people might like. Recover point gives us that additional advantage of synchronous replication or near synchronous replication with maybe asynchronous. Every 5 seconds I want to do pushes of replication without having to wait on that write acknowledgement from the other side. So we've also bundled in Cloud Array, which allows us to connect to any public cloud, or if you have Isilon or ECS internally as well, we can take an object store and use Cloud Array. It's this cloud gateway appliance. It's a VM that takes that object store and turns it into CIFS or NFS or, quite frankly, an iSCSI connection to that space, right? For all the VMs within the cluster. So, as an example, let's say I had 100 terabytes on some public cloud, and I needed a CIFS share. That 100 terabytes now becomes a CIFS share on my network for these VMs. Okay, and then I also give a volume from my existing data store within VxRail. I give a volume size to Cloud Array, and that becomes the local hot cache for that volume. Okay, so if it's 100 terabytes in the cloud, maybe I give it a 5 terabyte local volume. Now I'm locally caching the 5%, like the hottest 5% of data that sits within that public cloud. So, and it can manage and connect to multiple clouds simultaneously. All right, but the big idea for managing VxRail is that you will live and breathe within vCenter server. Okay, that's your single pane of glass view. That is your familiar interface where all of your integration, your add-ons, everything is already integrated and connected. Okay. Occasionally, you'll drop into VxRail Manager, as we were talking about, for installation, upgrades, etc. But then the big idea too is, remember, this is just vSphere in a box. So if you want to add on vRealize operations or VRA or have this work with NSX, etc., absolutely do it because it's just vSphere in a box, right? It's designed and supported by VMware. So let's talk about some of the vSAN key differentiators. I love this picture of Michael Dell. I am a huge fan of vSAN. It's kind of my baby. So to watch him holding the I am Captain vSAN sticker is pretty cool. So anyway, moving forward. It's a fun picture for me. So remember how we talked about vSAN being the engine for this hyper-converged car, right? There's a whole lot of advantages for it. There's two main ones that I want to make sure we talk about. The first one being kernel integration, and the second one being software-defined storage policies. So that kernel integration, what it shows us really is I've got VMs that are talking to vSphere, and vSphere is managing my storage media because vSphere has vSAN within it. Okay, it gives me greater performance, lower latency, greater VM density, etc. Rather than the other ways of doing it, which is this kind of abstracted piece where I've got a virtual storage appliance that allows me to run any hypervisor I want, but I've got a more indirect I/O path, and I'm having to feed resources, CPU and RAM, to those virtual storage appliances and to make sure they're happy and make sure they're managing the storage media correctly, etc. So Huge advantage for integrated in-kernel vSAN with vSphere. All right, and the second major one is storage policy-based management. And I love talking about this one. If you've test-driven a Tesla, you will already understand what storage policy-based management is like, okay? The comparison between test driving a normal car and test driving a Tesla is not unlike having to deal with and manage traditional external storage and having the beautiful, awesome experience of having storage policy-based management, okay? So what this means is the experience for storage policy-based management is when I turn on VxRail and I walk through that wizard, now I have a vSphere cluster. At no point in the wizard am I creating LUNs or metas or RAID groups or data stores or anything like that, okay? I am just simply giving it IP addresses, host names, and passwords. Now I have a vSphere cluster. I go and I provision some VMs, but one of the last steps in provisioning that VM is assigning a storage policy. And within that storage policy, I'm basically telling it how fast I want it to go and the resiliency I want it to have, okay? Akin to, if you go test drive a Tesla, you're going to get into it on the highway and you're going to say, this is how fast I want to go, this is what lane I want to stay in, this is as close as I want to get to any other cars. If I want to change lanes, I tell the car to change lanes and it will watch for me and determine, okay, now's a safe time to change lanes so I don't hit another car. Additionally, the car will park itself. This blew my mind when I went and test drove this. We got back to the parking garage and we rolled by a parking spot and it said, hey, it looks like you're trying to park the car. Would you like for me to park that for you? And at that point, I lost my mind. I turned to the guy and I'm like, okay, this is great. I'm on candid camera. Awesome. I'll give you a great reaction, etc. Whatever. He's like, no. Just hit accept on that big 80-inch screen in the middle of the thing that you see there that I've overlaid with the SPBM interface. And the car will just park itself. And it was genius. And the car just, it watched everything. It made sure it didn't bump into any other volumes, right? So you follow me on the analogy. And it backed up, and I was too close to the other cars. It pulled forward, and then it just backed in perfectly. And I got out, and it hit me. I was like, okay, so that's why when I walked out here, I was like, there's some crazy person out here perfectly parking all these Teslas. So they're all like 9 3/4 from the white line on either side, like 2.5 feet from that back wall. It's because it's all software driven, right? It's all policy based. So the same thing goes from a LUN management perspective. I guarantee you, I guarantee you that it's going to provide the best possible performance and manage that policy based on how it is that you say it better than anyone that's just sitting there trying to track all that stuff all the time and make decisions. Quite honestly, the fact that it pulls the human effect out of having to make decisions, it reduces complexity, it reduces risk, and therefore reduces downtime and decreases costs associated with that. That's all because of that policy-based management. So your homework assignment then is to go and do a trial of vSAN if you haven't already used it already, and then at the same time go and test drive a Tesla. And maybe you can actually manage your storage policies on the Tesla interface there while you're driving, because it's driving for you. All right, but the big idea is that this is an appliance that's delivering vSphere and it's fully loaded, okay? So it's got all the data services you want. It's got deduplication, it's got compression, it's got erasure coding, it's got cloud tiering, it's got quality of service, so I can make sure that these VMs that I care more about get performance and these don't get performance, or they're maxed out, they can't go above a certain level. It's got all the data protection you want. Anything from backup to archive to up to point-in-time replication or synchronous, asynchronous type replication, or even stretched clusters, it's all included, okay? vSAN has the capability to define fault domains, and therefore I can have nodes that are within a data center. I can put them in separate racks, and they can understand that they're in different racks, and they can intelligently replicate to the other nodes in another rack, because it gets that one rack can be a fault domain, and that rack can fail together. And so what we can do is take those fault domains that are in separate racks, and we can move them to different rows, we can move them to different floors, or put them in different buildings. Okay, we can stretch them across a metro area, and now at this point I've got a metro cluster. I've got a stretched metro cluster where when I write to this, when I've got this VM writing to data on this side, it's synchronously writing over here, getting an acknowledgement back, etc. So if I lose access to this site, the site goes dark, my VMs are going to automatically reboot in the second site, and bam, I'm up and running, right? Beautiful, beautiful thing, and it's included. Additionally, because this is one system, right, and the idea is for it to be a single appliance, you have one global support team for this specific system. So anything that you need help with on the system, whether it's a power supply, or a DIMM slot, or something's going on with vCenter or a VM kernel NIC port or vSphere integration for something or whatever, you call this one team, and this one team supports that whole ecosystem, and that's all they do. They live, eat, and breathe support for VxRail. All right, so thank y'all for your time. To wrap it up, VxRail is the best, it's the most, it's the closest. So that's all I've got, and I know y'all are looking forward to watching Rogue One, and I will step back and let y'all get to it. So thank you, Mark, and thank you, Pillium. I appreciate you giving me some time to go over this with everyone. All right, don't forget, you can text me or hit me up on Twitter. There's my contact info again. Would love to help y'all out. If you're looking at trying to figure this stuff out, or if you have more questions, if there's something that I said that didn't quite make sense, or if you want to go grab lunch sometime or whatever, give me a shout. All right, see you guys. Have fun. Enjoy the movie.